Oh, okay. So just activate it and run it. Okay. All right, so I'm going to show you two different weldments here today. I'll start with the one that I have here. So what I have going on here, I'll try to zoom in if I can. Uh, zoom. I maybe zoom all the way. Oh no, there we go. Okay. Um, up a little bit. All right. So what I'm making here, I have a fixture that I've made here, and it's just going to hold on these two aluminum pieces. This is 1/8 inch 6061 aluminum. I've laser cut these, and they actually interlock with each other just with small tabs at the end, and that's just to make it a little bit more repeatable. But yeah, I have 6061 aluminum 1/8 inch, and this is the weld that we're going to be making here. And let me see if I can actually zoom in more on that so you can see final product before you see the weld. So I'm going to show you the robot welding it, and then I'm going to do a quick example afterwards of how I would go about making this program. So you can see here, there's the weld, full penetration on the backside. This is started as a half overlap. I overlapped it a bit, so we have a half overlap and it's still fully penetrating there. That's what you're going to see here in just a second. We're using a 5356 aluminum welding wire. And yeah, so let me set up this fixture here. I'm going to place my parts on the jig. I'm using just binder clips to hold the part on here. Not the most elegant solution, but it works. All right, so we've got our parts on our fixture, and I'm just using a preset condition from IPG to weld this. So this is just setting L8, and I've made a slight adjustment to the power and the width of the laser beam. So yeah, I'm going to go ahead and enable weld. Put on my welding helmet, and I'll go ahead and run this program. So this is traveling, the robot's traveling at 55 centimeters a minute, and the wire feed is feeding out at about 70 centimeters a minute right now. Now, I've just done a little bit of figuring in order to find out those parameters. I had about 3 test parts before I was able to make a successful weld. Once I figured out the settings I needed, I've now made about 10 or 11 of these things, 0 failures. So yeah, that's the weld. I'll go ahead and disable weld here. And then I'm going to take this tablet over to the other side of the table so I can kind of demonstrate for you what it looks like to create a program like that. I'm going to set this down over here. All right, so I'm going to set up another setup of these parts, and I will walk you step by step on what it looks like to make this program. Now, this is a pretty simple weld, straight line outside corner joint, but if you can imagine, the main difference here would just be altering the motion of the robot. The welding control is going to be pretty much the same. no matter what we're doing. Yeah, so let me zoom out a little bit. Okay, so I'm gonna start by creating a new program. I'm gonna go to select program. Gonna give me the option for new. I'll give it a name and we will do webinar demo. Okay. All right. So what I'm going to start with is a blank timeline. So I have this blank canvas to work with. I have a library of icons that I can choose from. If I can get a close-up picture of this. It's going to be a little bit of a balance showing you the screen and the programming at the same time. But if you can see here, we have this blank timeline here, and we have this library of icons which we can choose from in order to control the robot and the laser. So what I'm going to start with is a home position. Right now, the robot is up and out of the way, so I consider that to be a good home position in this instance. I have plenty of space to change my part after I've welded it. And yeah, so that I'm going to start out with a home position. So for home or for motion, I'm going to go to the motion tab. I'm going to select, I have to enable teach here. I'm going to drag up a joint maneuver, and then I can adjust my speed of the robot. So when it goes back home, I'm just going to put it at, I don't know, 75% overall speed. So when I dragged that icon up there, it now captured the positional data of the robot. So if I could zoom in a little more. Okay, that's better. So you can see this data here for the X, Y, Z, roll, pitch, and yaw is now captured. And if I wanted to make a change to that, I would move the robot into the position which I wanted it to be in, and I'd click this touch up button. I'd click OK, and it would override that information. So that's how all of the positional data points are going to be done. I will move the robot where I want it, drag an icon that gives either a joint or a linear move, and then I can adjust this data if necessary, and my speeds down here. So that's very easy. I'll zoom back out, and I'll zoom back in once I do some laser control icons. Okay, so my next position is going to be an approach. So I'm going to basically move this, my welding torch somewhere up right above where I want to start my weld, ensuring that I'm clearing anything on my table. So I'm just going to kind of move over to right here. I don't have anything in the way, so I'll just get somewhere close. And from that point, I'll then slow my motions down to avoid an impact, say, if I were to program it incorrectly. So let me go to robot operation. There's a couple ways to do this. I can jog it. This is kind of my preferred method. May not be yours, it may be, but you can see I can just jog the robot in different directions here. Or I can put it in manual guide teach mode. And right now I'm hands-free on the tablet. You can see I'm able to move the robot around. Very easy. That's translation mode. The torch angle stays the same. I can put it in free mode. I can then move any part of the robot however I see fit. I can also put it in rotation mode where it'll rotate about the tool center point, which is right about here. I'm just reaching up and grabbing the arm. Now, even if I move the robot from over here, I'm gonna walk back over here. I'll move the robot arm from way back here. You see that it'll rotate about that TCP. So these can all be handy, and you may prefer to program the robot by hand. Like I said, it's just not my preferred method, but you know, you can do it whatever way you like. Okay, so now what I'm going to do is I'm going to jog to that position I was talking about. We'll go over here. One trick that I like to do is I like to use my the level on my iPhone to find the angles. So I know that when I'm welding with this with the robot, I tend to use about a 20-degree angle into the surface. So
So I'll just go on my iPhone here. I'm gonna go to the level tool, and I'm gonna ensure that I'm leveled this way first. So I'll put it here. I'm at a 0. Let's see if you can see that green on the screen. Lights up green, that's 0. And then I'll put it on the torch at 37 degrees. So I'm gonna just kind of move that a bit till I get to about 20, 19 degrees. It's close enough. So this is a real handy tool. Kind of, you can use an actual level gauge or something, but the iPhone one seems to work just fine for what I'm doing here. So from there, I'm going to basically jog it into this a position just above my start point. You guys can all hear and see me okay?
Yep.
Yes, sir.
All right. Make sure I'm not talking to the wall. Okay. Kind of eyeballing it here. Obviously, when I'm actually making this weld program, I'm going to be a little bit more precise with my positioning, but I'm just trying to give you guys a gist here. Let's see. So that's a good approach point. I'm above the part, maybe 4 inches or so. And so I'll move at a higher rate of speed to here, and then I'll slow down my motion as I get closer to the point. So I'm just going to drag up another positional data or a position icon. So that's a linear move. I'll go in a straight line from where I started to where I am now. Now I'm going to set my speed here, and pardon me for this, but I'm used to centimeters per minute. The LightWELD wire feeders use centimeters per minute, so I've familiarized myself with that unit over inches, even though I'm in the US here. So I'm setting it at 750 centimeters per minute for that motion. I'm going to make it a continuous motion because I don't care very much if it actually gets to this exact point. I just want it to pass through there on its way to this point. That point will be a fine position. So I'm going to move in Z minus. I have it set very slow, so I'm careful not to move the robot too abruptly close to other objects. And then I'm going to basically put the end of, I'm going to put the end of my wire where I want the weld to start. So what I didn't do is normally what I do is I put on this teaching tip. I've basically set up a nozzle with the correct length of wire to teach that point. But right now I have it set up with just the wire feeder on there. I'm just going to leave it for now for the demonstration, but typically I'll switch out to this tip just to teach the points. And that's very easy to do. It's one threaded collet, and you just change out the nozzle. So I have my start position here. So I'm going to go back to programming and make another point. The speed will be slower. Approaching that point, it'll be a fine motion. Then my next step is I'm going to put a wait command. So there's a stopwatch icon that will just let you put a pause, basically. So I have a little stopwatch icon. I'm going to just put a 1 or 2 second pause here. And the reason I do that is that when the robot's moving, if the table or anything has a small movement to it, like a vibration, I just want that to settle before my weld starts so it doesn't propagate into my weld. So I have my wait command, and then I'm going to put my laser on command. So my laser on command is going to allow me to set dwell times for a few things, power ramp up, gas free flow, basically how long the robot waits for the laser to do its thing. So I don't really need it to wait at the start of this one. Change the timing. I'm going to enable the wire feeder, select which wire feeder I'm using, and then set my wire speed. So this program was about 70 centimeters a minute. So now what it's going to do, essentially, it's going to go to this point that I've taught. It's going to wait 2 seconds for any vibrations, and then it's going to fire the laser, which is doing the sequence of triggers that you do by hand with the with the LightWELD. I apologize. The camera, for some reason, this camera randomly just goes to its home position. I have my helper helping out now with him, David. He's going to be showing you some welding in a few minutes here. So yeah, it's going to go here. It's going to fire the laser, and then what it's going to do is move to whatever point we program next. So that's what we do next. We're going to move away from the part a little bit, and then we'll just scan over. This being a straight line weld, there's only 2 points to teach. It's really easy. If you had a circle, there's going to be like 3 points through every arc that you're going to need to program. I'm sure if you guys have seen my videos on YouTube, or you can find something of me doing something similar to that. All right, so I'm going to teach that as my end position. Not sure that camera is there, but yeah, so that's my end position. Once again, linear move. I want it to go in a straight line from here to here. You don't need to zoom in. I think they have seen the recording of the points enough, David. Okay, so I'm just going to set my weld speed. I think that one I did before was 55 centimeters per minute weld speed, fine motion. And then right after that, I can do my laser off, where I can control my dwells for laser ramp down. So how long the robot waits for the laser to finish its ramping down process of the power. Then again, I like to a lot of times put a pause at the end in case I'm working with a material like stainless steel and I need a gas post flow to get good gas coverage at the end. And then there's a confirmation, laser off confirmation, which basically the robot is looking for the laser to verify that it has finished all its processes before moving on. So I'll just set a time that's longer than the ramp down time. So that's 700 seconds. I'll just put 700 milliseconds. I'll put 1000 milliseconds, which is 1 second. And then pretty much the reverse order of the beginning. I'm going to make a point where I move away from the part. So this is my D approach position here. Record a linear move, adjust my speed. Okay, and then I'm going to copy paste the home position. It's just, I want it to go right back to that home. So I'll click and hold, and then I'll press copy. And then I can drag and drop and paste my home position because I just want it to go to that exact same point. Okay, so and I'll go ahead and I'll dry run this program for you so you can see how the motion will work. I won't directly fire the laser since I didn't spend time getting it, all the positions just right in this demo. But yeah, so let me go ahead and deactivate teaching. I have the weld off, and then I'll go ahead and play it. Typically, I'd play it a little bit slower first time, but I'm not gonna, it won't crash. I'm fairly confident. So it goes to that beginning point. It would do its 2-second pause, fire the laser, welding, 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 and then yeah. Zoom out, David. Zoom out. All right, so then you'll see it go right back to its home position. Say hello, guys. Okay. All right, so that was a demonstration of the weld on 6061 aluminum CRX 25 with the LightBOT and aluminum wire feed. So now I'm going to show you, I'm going to have David run this other program. We have another weld program going on here. This one is making use of a digital output to control rotary device. So we're basically using a signal to basically just turn on this rotary, and we wait a certain amount of time. This is a real simple integration using a DC motor to rotate the part. Kind However, you could go more in depth with this and use a rotary that's using a Fanuc servo motor that the Fanuc can then recognize the position of, and it can do coordinated motion with that. We have it done real simple here. This is gonna do a, you're gonna like this one. This one's gonna spin the part, clean the material, weld it, re-clean the material. And also you're gonna see another little trick where the robot actually is gonna flick the switch. Yeah, we're gonna change direction because when we're gonna try to passivate the stainless steel, and in order to do that, you need to hit it from 2 different directions. So we're gonna actually have the rotary change direction. This is using the cleaning mode, and this one is being done with the LightWELD 2000 XR. This is the new system here, 2000 watts. This is 1/8-inch diameter wall thickness stainless pipe, and it'll fully penetrate this pipe with no problems at all. Yeah, go ahead and run it. You want dry run off? Weld enable. Here we go. Okay, so it's coming from its home position down to the part. Now doing its cleaning function. From that distance, I'm not sure if you could see, but there'll be a clean stripe right around where the weld joint is. Probably a little hard to see from that distance, but yeah. Okay, now we're welding. 1100 watts. Looks like it's modulating. So laser's actually pulsing on and off. All right, and it's cleaning from one direction. And then the robot will come around and change the direction of the rotary. So this is a 15mm wide cleaning pass to take care of any heat affected zone around the weld. Whereas the first one was a narrow cleaning pass just to clean the actual weld joint. Now the robot will do some acrobatics. It's completely unnecessary, but it's just to show you, you know, some of the versatility and what you can do. We were just having a good time with it. And now it's cleaning the opposite direction. And it'll flip the switch back for the next part that we'll run. We actually run a welding job at our shop here, just like this, on a regular basis, and we're able to tackle about 300 parts in a day. And that's, you know, I wouldn't say it's a full 8-hour day of welding, but it's short work of it. You stand there, you undo the rotary, take the part out, put the new one in, press go. Really easy. Okay. Any questions about what you've seen here before we move on to doing some of the handheld stuff?
So you have it set up to where the robot will go over there and flick the switch. Why would be my question.
Honestly, we just kind of did that because we saw it. We saw it in another application where there was a robot that was operating a CNC lathe, and it would open the door, exchange parts, and then close the door, and then press the start button on the actual lathe. And we just thought it was kind of fun to have it flick the switch. We could very easily do it ourselves, but it also partially eliminates some chance of human error. Somebody might forget to flick the switch in the middle of that process, whereas the robot's it has its process built in to go and do that.
Oh, sweet, cool.
We could also, you know, have removed the switch, hooked up a relay, and had the robot activate a relay, which would flip the switch back and forth if we wanted to do that also.
You gotcha. All right, cool.
So hey, Evan, it looks like you know, this is a good example using like the rotary system too. Do you guys have any integration with rotary systems currently so that the robot would know the position of the part specifically on there?
Yeah, we haven't used it ourselves at our location, but I have been to a Fanuc location and seen that firsthand. There was a linear rail and a rotary. Really, you can make it work with anything that's powered by a or that has the motion controlled by a Fanuc servo motor. So as long as the Fanuc controller is only able to recognize the encoder positions from Fanuc motors. So whatever device you have, if it has a Fanuc motor, the Fanuc can control it. So that might even, you know, that could basically open you up to using anything you want as long as you can adapt a Fanuc servo to it. And there are a few devices available like that. We haven't used them ourselves.
Great, thanks.
No problem.
Can the co-robot kit be used with any model of the LightWELD system?
Yes, yeah, and it can be retrofit. You can use it with a brand new one. You can use it with the very first LightWELD that came out. The only difference would be is the older ones would need a software update on the LightWELD in order to be able to accept the socket messaging coming from the Fanuc.
Got you. Thank you.
No problem. Okay, so if there's no more questions on the robot, then we will move on to the handheld booth where there is a double wire feeder setup that we'd like to show you guys. And we're gonna go over there, change the camera,